Hello, everyone, and welcome to the Apache Flink Ask Me Anything, hosted by Aiven and Ververica. My name is Anna. I'm a community manager at Aiven, and today I'm joined by the Apache Flink PMC and Ververica Senior Product Manager Martijn Visser and Francesco Tisiot, Developer Advocate at Aiven. Before we start, we have some housekeeping items. So the live stream is recorded and it will be available on YouTube right after. Please remember to be mindful of others and respectful in the chat. Some of you have submitted questions in advance, but we're here to answer your questions in the chat as well. So please post them there. As for the agenda, we will start with a brief introduction to Flink SQL and move on to the questions right after. Francesco, Martijn, the stage is now yours.
Thanks a lot, Anna. Thanks for the introduction and welcome everyone. So we are here in the Flink SQL AMA, but before going into the AMA, we believe it was good to share why we need to talk about Flink SQL. And in order to understand why we need to talk about Flink SQL, let's start with understanding why we need Flink. So we have been used to companies that had an internal or external application that was usually generating data and storing the data to a backend database. Now, the data stored in this backend database was interesting for the application itself, but not only. It was interesting for other parts of the company that were willing to extract the data from this source database, transform and create data marts, analyze this data further. But, most of the time, they were not allowed to query every second, every time they wanted the source database, because that could impact the performance of the database on the application side. So the users of the application could feel the application going slower because we were hitting the database with huge select statements. So most of the time, this extraction was allowed, but only during overnight. We were extracting the data, doing transformation, and populating a data mart. The next morning, the data analyst was waking up, look, magnificent pajama with full of stars, and looking at a perfectly defined dashboard. It was all good until it was not good at all, because by the time that the analyst was looking at the dashboard, the data in the dashboard was already old. The analyst was checking yesterday's situation with 24 hours of delay. And old is kind of a vague term. You can be old of 24 hours, but you can reduce this delay. You can be, for example, old of 6 hours, reducing the delay or running the ETL every 6 hours. You could reduce even more, running the ETLs every 4 hours, every 2 hours, every 5 minutes. Still, you are reducing a delay, but the delay is always there. You are creating ETLs that are approaching the data with a batch mode. You're running your query every 5 minutes. What if you could do analysis and data pipelines which act in streaming mode? So as soon as an event is generated in the database, the data pipeline starts crunching it and does the transformations and pushes the transformation in the downstream data technologies. Well, this is what Flink does. With Flink, we can do data streaming from a huge variety of data sources to a huge variety of data targets. And Flink, it's a beautiful open source data platform, data pipeline definition, and it's even more, it's distributed. So it can scale to handle huge data volumes. And it's very smart when scaling, because when you create a query against Flink SQL, it basically divides and conquer. It divides the query using the query key across the nodes, and then solves the query in that mode. So if you need to handle huge data volumes, you maybe need only to add additional nodes to the cluster. As I said before, the other beauty of Flink is that it can work with a multitude of data sources and data targets. So you can ingest data from almost any database. You can ingest data from Apache Kafka, which is another open source data platform for streaming. And you can push the result in a huge variety of data formats, including Kafka, Elasticsearch, OpenSearch, Cassandra. The result of your streaming data pipeline could just be a tweet. Now, Martijn, can you tell us a little bit more about what options we have with Flink SQL, with Flink in general, sorry.
Yes, thank you, Francesco. Thanks for the introduction, everyone. I would like to tell you a little bit more on the different options that you have when you're actually going to create your data pipelines. Flink offers multiple ways for you to declare those. If we go from right to left, you can have the more explicit control, which means that you can do whatever you want. We use that in the statefun side of Apache Flink, but also in the data stream API perspective, you can use that. But if you want to have more declarative ways to define your pipeline, we offer the table API and, of course, SQL being the most declarative option out there. And if we go to the next one, we will see why we think that SQL is so handy from that perspective. If you just have a comparison about different roles out there, different people that are working in organizations, and if we then take out data analysts and data engineers, who are two traditional roles who exist in a lot of data organizations. Data analysts are all about translating data into information. They possess a lot of domain knowledge. And most of the times they are already quite experienced in SQL, coming from that batch-oriented background from that perspective. While data engineers, who usually work for something on the IT organization, they are assigned to projects or to applications, and they are more used to writing their code in either Java or Python or Scala or something else like that. But the interesting part is, of course, if we take an example of how many data analysts and how many data engineers are out there. And the interesting part is that the number of data analysts out there is much, much higher than the number of data engineers. So what if you can have that gigantic group of data analysts, you can offer them with the tools in order for them to reach a faster time to market or faster time to delivery? That's where really the power of Flink SQL lies, because if you can empower that group and you can leverage that huge volume of people out there, you will have those abilities in your organization. And that's why we think Flink SQL is so important from that perspective. But what is actually a difference from a batch and from a SQL perspective? I have two nice overviews for that. If you look at the batch-oriented model, or batch-oriented data source, I should actually say, let's say that we have a user Mary, a user Bob, a user Mary, and a user Liz. Those are 4 different records that are appearing over time. And the difference between batch, or the similarity of batch, is that all of the data is known at the moment when you are actually processing them. So if you have that 24-hour-old data, all the data from yesterday has appeared. So when you are creating just a simple count of the amount of users, you can take all the data that's available at that moment in time and then display the result that is shown here on the right, with Mary appearing 2 times. But the difference part about streaming is actually that all the records are individually processed. So that means that if we have the same diagram, then you will see that actually every time that something is happening, it will be processed. That means that the first time that Mary is appearing, Mary will appear with a count of 1. Then Bob will appear with a count of 1. Mary again comes along, which means that that previous result is dead at that moment updated from a count 1 to a count 2 in this example. And only then at the end, Liz is added. That means that in stream processing, that we have both inserts, but also retractions happen because data can change over time. That's some of the differences that we have in batch and stream processing.
Okay, let's conclude with showing a little bit what we can do with Flink. And before joining Aiven, I was coming from the database world, so I was used to use the database SQL. And Flink SQL is really rich. It's comparable with the SQL that you find, for example, in a Postgres database, but it's for streaming. What can you do in streaming? Well, you can do pretty much the same thing that you can do in batch mode, but with some particular bits that are really focused on streaming. For example, you can do filtering. If you have the data of all the restaurants in Italy, you may want to filter only the restaurants for Milan. You can join data. And as we saw earlier on, you can join data coming from different technologies. So you can join data from Kafka topic together with a reference table coming from Postgres. And you can take the result of your computation and push it to, I don't know, an S3 bucket. You can then aggregate the data. So you can compute, for example, the amount of orders that you have per city, or in this kind of streaming mode, it's very intuitive to, for example, calculate the average number of pizza orders that we are receiving in the restaurants of Milan. So all this kind of what's happening now in my environment is stuff that we can compute with Flink. Then you can explode the data. And this is really interesting where, for example, you have nested data structure. So if you think about, a food order, you have the order itself, and then the list of ingredients, the list of dishes that you want within the order. With this explosion option of Flink SQL, you can create one event for each ingredient, for each dish within the order. Then you can also do advanced pattern detection. There is an option, Match Recognize, that allows you to define what is the pattern that you are looking for, and then flag when you find instances of that pattern happening. Again, when you think about patterns, the usual reference is stock market. You may be willing to purchase stocks when you see the price going up for 5 minutes and then going down for the consecutive 5 minutes intervals. And you can do all of that just by defining the pattern in SQL. The last bit that you can do is you can change the shape of the data. You can take data which are defined in JSON format in a Kafka topic, change the shape, and push it to a relational database. Flink SQL allows you to do this and much, much more. Now, what we are going to share here is a list of resources, and we will discuss about those resources during the AMA. I believe this was just a little bit of an overview to raise your appetite on Flink and Flink SQL. Now, let's start with the AMA. Back to you, Anna.
Thank you both for the great introduction to Flink SQL. Now, I have a question to Martijn. The first question, isn't Flink SQL a quote-unquote false friend when coming from batch ETLs?
That's a very good question. I think one of the key elements when these questions are appearing is when people are making a transition coming from a batch-oriented world and moving towards that streaming-oriented world. And I think that the key differentiator in here is the different mindset that you need to have from that perspective. Because what we say in batch or in bounded data is that it's a different way of thinking, because like I've shown before, because not all the data is there anymore in a streaming fashion, you will have those continuously updated events coming in, which means that you will have retractions or inserts, which is something that is not common in batches, because then it's abstracted away, it's hidden actually from the user. So I don't think that it's a false friend from that perspective, but I think it's a major new advantage for users out there. But you need to understand and learn what is those differences between those two data sources or ways of getting data processed. And when you will try and experiment with that, you will figure out that it's not a false friend, but it's probably your new best friend.
Thank you, Martijn. That was a great answer. Now on to Francesco. How can you test Flink SQL? Can you maybe share some advice, or are there some tools that can help you with testing phase?
Yep. Again, it's a good question because it's tricky. So testing SQL it's tricky because you're not testing only the logic. You are also testing the data. And when you do that with, for example, batches or fixed data sets, it's extremely easy because you take part of the problem out. So the source data set, it's fixed. With Flink and with streaming in general, this is a little bit more complex. But what you can do is still, again, divide the problem. First of all, usually what you could do, for example, is to fix the source of data and check that the data pipeline creates the same results, always starting from the same data set. And in order to generate that data set, you can take different ways. You can, for example, write your source data set into a file and use that file as a source. Or there is also nice utility that allows you to create fake data. And there is a fake data generator for Apache Flink that you can use in order to produce fake data that looks like what you're expecting. For example, as I said earlier on, you may want to test your data pipeline against the pizza orders across all the pizzerias in the north of Italy. You can create that kind of fake data that are close to what your production data look like with this fake data generator. And then you can sync the data to a file that you can compare to with the expected result. You can sync the data to a database where you can do comparison with the previous run of the same SQL. So you can solve that static bit of SQL. The streaming part is, again, a little bit tricky because what happens with late arrival of events, what happens with all the edge cases. And for those, you will need to build some sort of streaming data source. The file system option, the file option that I described before is static, but the fake data generator allows you to create a streaming data source that you can use for your testing, and allows you also to set the seed of the fake data generator so you can have repetitive results as input of your data platform. I believe this is a good way to test that our Flink SQL or the data pipeline works as expected.
Thank you, Francesco. I'm just posting in the chat a link to Flink Faker. We also will have it in the resources for those who want to check it out. For the next question, which is a question to Martijn, what should I pay attention to when creating my first SQL data pipelines?
I think there are a couple of things. I think the biggest one is, at first, you just have to try it. There's nothing that should be holding you back in order to try it. So go to the website, download it, and you can run it locally, and you can just try and experiment with it. But I think there are a couple of things that are important. One of the things that you should definitely think about is what we call potential impact on state. Let's say that you are running a normal join, so that you would join two sets of data. If you are doing joins in a streaming fashion, it means that you need to keep all the data that has appeared in the past in the state of the application as well, because it might be that in the future, actually something which matches in your join could appear in there as well. And that means that your state can grow really large. And that could ultimately mean that you would either run out of memory or you have to add more machines in order to cater for it. One of the easier ways to mitigate it from that perspective is to apply something which is called window table valued functions, which means that you are going to create smaller windows of data, which will have a better impact on your performance. Or something else which is called temporal joins, which means that you are not going to match it for any moment in time, but only for a specific moment in time. Like if you would do if you would have a currency and you would like to see the exchange rate for that, exchange rates change themselves over time. So you could apply a temporal join to see over time how the exchange rate would actually fit with that. One other thing that I think is also really helpful is that in Flink SQL, you have something which is called the explain command. when you are executing that command, it will actually explain to you how that SQL statement is being transformed into an optimized plan. Because what SQL really does, it's doing a lot of optimizations to be as quick and as good as possible. And explain will actually show you in more detail how those transformations would look like. That would be really helpful when you're starting out with that. And of course, don't forget to check out the user interface of Flink, because that can actually give you real-time insights on the data that's being processed and all the different things that could be impacted by your statement. You will get a lot of information from the Flink SQL user interface, or from the Flink user interface.
Thank you, Martijn. That's some really good advice. So when it comes to newcomers or beginners with Flink SQL, Francesco, where can I start with it?
Okay, there are a lot of places where you can start. First of all, like, follow Martijn's suggestions, because there are some good points about thinking what you are building for. Second thing is, depending on like what are your capabilities, what you want to do, there are different places where you can go. So if you want to have a easy experience where you have a minimal setup of Flink, you could go, for example, for the SQL client on Docker. With Docker, you just need Docker. You create an instance of Flink, which contains a handy SQL client where you can start creating your queries in SQL. But that's only the mechanism that allows you to start Flink. What you need to do is to check out the details of the Flink SQL. So if you have some SQL knowledge coming from the database, you may find interesting browsing all the list of available SQL functions. And as I said earlier on, there are a lot of them, and they cover a lot of use cases. If you want to see some of them in action and trying to understand what is the potential of some of them, or on the other side, if you have a problem and you are trying to understand how a certain SQL function can help you, check out also the Flink SQL cookbook, because contains pre-created kind of exercise where you face a problem and then you understand how you can use a certain or a certain subset of the Flink SQL functions in order to solve that problem. So yeah, start with Docker. Then there are also some fully managed service, like the one from Aiven, for example. But then also check out the documentation, because the Flink documentation is really rich, really interesting, and it covers a lot of the use cases that you can find in your day-to-day basis.
Thank you, Francesco. I'm going to once again post the cookbook in the chat. And on to the next question, which is a question to Martijn on when not to use SQL.
Okay, I think there are a couple of reasons for that. It's of course about if you want to have that declarative option in SQL. If you are more of a avid user of either Java or Scala or Python, then I would say by all means go for one of the other options, like the Table API or the Data Stream API from that perspective. One of the other things that I think is also important where SQL is not really a good fit is when you want to have explicit controls over time and state. So if you want to have something that allows you to set custom moments when something needs to happen, if you want to have really that lower fine-grained access to those, you should not use SQL from that perspective. And I think if you are really want to build data event-driven applications from that perspective, which allow you to use either process functions and those time and state elements, then I would say don't use SQL, but then go for either the Table API or for the Data Stream API.
Thank you. That's some really good tips. Now we have some questions about optimizations. If there are optimizations within Flink SQL to support different window aggregations. Francesco, can you perhaps answer that question?
So I believe from my experience with Flink SQL and windowing, you have to define how much does the window last, more or less. And so from my experience, you will have to write a couple of queries if you have two different time windows. I'm taking this also from a mathematical approach. So for example, if you have to count the events happening in 5 minutes and count the events happening in 10 minutes, well, you could think about summing up two windows in order to arrive to the 10 minutes. But on the other side, for example, when you have to count the distinct clients, the distinct visitors that you get in the two-time windows, well, you cannot just sum the data. So from my experience, and Martijn, correct me if I'm wrong, but you will need to declare those two windows as separate in order to arrive to the correct calculation.
Yes, I think you can also probably use the window table valued functions quite handy in those cases as well. They will provide you with a lot of good opportunities or
I think there are some technical difficulties on Martijn's side.
Yep.
Oh, he's back.
I'm back. I hope I'm still back. I saw that you were dropped off for a moment, so let me just repeat it. I think if you are one of the things that could also help you out is the window table valued functions from that perspective, especially if you're looking into cumulative or aggregations from that perspective. Definitely, those are your best option to get to the right results.
Thank you both. The next question is about side output support within Flink SQL. If we can perhaps give some details and also explain what it is. Francesco, do you want to start?
Yep. So if I understood correctly, the side output is a way to define not only you have an input or one or more inputs and an output, but you create multiple outputs that can have different shapes. Now, in my experience, again, with Flink, you have just one output, but I would be interested in Martijn's opinion about what's coming next.
Yeah, I think one of the key elements when we see a side output being interesting for SQL users is when we are talking about late events from that perspective. So when you have let's say an expectation that all events should arrive within a minute or so, but what do you do with the events that are actually coming in after those minutes? That's when a lot of people are interested in a side output from that perspective. And I think what you can then use in Flink SQL is something which is called a current watermark function that gives you insight on the current timing of the watermark in Flink, which is used for internal time processing. And you can also use sending data that is late from that perspective, for example, to a different Kafka topic or to a separate data sync from that perspective. And also in the SQL cookbook, there's a nice recipe about this as well.
Thank you. The next question is, can I upgrade my Flink SQL application? It's a question to Martijn.
That is something that is not yet possible in the currently released Flink SQL applications. I'm then specifically looking at the ones where, let's say, the query stays the same, but you want to upgrade from, let's say, Flink 1.10 to Flink 1.11. There's currently no guarantee for that the upgrade can actually work. But as of Flink 1.15, which should be released hopefully in the next couple of weeks, there will be a new beta feature available in there, which will actually allow you to have a stateful upgrade when we go from one Flink version to another Flink version. So hold on to your horses a little bit longer. It will be coming rather soon. And then hopefully this, I think, is one of the last big topics that is delaying a major adoption of Flink SQL for big use cases where state is really important. So hopefully in the next release, we will have that one covered as well.
Sounds exciting. Martijn, could you perhaps give any recommendations for controlling or assigning unique identifiers to avoid DAGs from breaking with, for example, an addition of a new column?
That's a good one. There is on the Flink documentation a nice overview of that, about potential things that you can do and currently cannot do. With UID assignments, that is something that is done under the hood as well in the current Flink releases, but it's also something that we will improve in future releases. It's also with regards to the naming of the operators, for example, because there are currently a concatenation of different values coming in from the SQL statement, but those will also be improved in the next Flink release.
Thank you. So I have another question, which is a little bit, it's asked pretty often in this space, and perhaps you both can give your opinions on that. So where does Flink SQL stand compared to Confluent kSQL? Francesco, do you want to start with that perhaps?
It's indeed an interesting question. Also because, let me start introducing what is kSQL. kSQL, it's a way to define SQL transformations on top of Kafka topics. And that is, I believe, the first distinction. With kSQL, you can work only on top of Kafka, only on top of Kafka topics, and the source and the target needs to be in Kafka. With Flink, you can work on top of Kafka, on top of a lot of databases. You don't need to pass through Kafka. Yes, we know that Kafka is used in a lot of use cases in this kind of streaming patterns, but it's not the only technology. We could, for example, with Flink, there is a CDC connector allowing us to track the changes happening in a database in near real time. We can use Pulsar instead of Kafka and still keep our data pipelines in Flink. I believe the difference between Flink and kSQL is that you are basically taking away your transformation data pipelines from where the data is running. So in the future, you want to swap the engine which is behind your data, still your data pipelines can stay in Flink. This is my main differentiator. In terms of capabilities, I would say that they are pretty similar. They can, if you limit the scope to Kafka, they can parse data in various formats. They can apply a lot of different transformation. They can parse, for example, JSON, advanced JSON function are coming in Flink SQL as well, enabling us to do a lot more. So Flink SQL is really rich. And if you compare the SQL function, there is no much difference between the two, or maybe you have something more in Flink.
Yeah, and if I may add to that, I think one of the other elements that's also a differentiator between Flink SQL and kSQL is that from a Flink perspective, batch is a special case of streaming. But for Flink SQL, you can also apply for your batch applications or your batch jobs from that perspective. And that means that it gives you a nice option to transition from batch processing towards stream processing as well.
Thank you for the answers. So kind of a last question on our questions list, actually, but perhaps you guys can dive into this a little bit more. I'm interested to hear what's the coolest Flink SQL function in your opinion and why? Perhaps Francesco?
Well, there are a lot. There are a lot, and the more that I try new functions, the more I enjoy having them and exploring them. I have a particular love for anything that involves regular expressions. That's because I use regular expression in the past to solve the problems, and I use regular expression in the past to even create more problems than the one that I started with. So there is a lot of, there are a few, Flink functions where you can, for example, use regular expression to parse strings, to extract parts of the string, or to mutate the string itself. So those kind of functions which, yes, they accept one parameter, but the parameter itself is something that you can somehow write as a code, is where I'm really interested. And the regular expression usage that you can have with all the strings that you have in your dataset is something really cool that is available in Flink SQL.
I think you're missing out on you're not missing out, because I know it's a personal favorite of you as well. But I think the match recognize function is a favorite in among SQL users as well. The match recognize function allows you to define, let's say, the patterns that you're interested in for detecting from that perspective. It's a much used function by Flink SQL users. One of my personal favorites is actually the new and upcoming JSON functions, because JSON is so common to use or get in from your data, sources. And with the new JSON functions, it allows you to extract JSON values from JSON strings. You can also serialize to JSON, or you can build your own JSON objects. And I think it's one of the missing pieces in order to get to a event-driven application building in SQL itself. But it also going to give you so much easier options just to get proper data out of your JSON formatted data from that perspective.
I believe, like, you touch a good point, like match recognize is indeed really powerful, because allows you to do one of the most common things that you do when you want to check the data flying. So it's not only calculating, for example, windows, which you have plenty of options, but also comparing either row events or aggregated windows one to the other. So you may want to understand if the amount of sales in the last 5 minutes is higher and lower than the current amount. Or you may want to check like a pipeline of 10 different windows because you are analyzing the data like that. And Match Recognize allows you to do that. And it's like, I use Match Recognize in other technologies first. And the amount of things that you can specify in Flink, and knowing the fact that you are specifying, you are defining these things, and you will analyze these windows or these events as soon as they fly by, it's spectacular. The other bit that I want to add that I really love about Flink SQL is, again, kind of not probably a function, but something that you do before. It's the table definition. Because, you know, as I said before, you might have the table in a topic in JSON format. The next iteration of your team behind Kafka is, you know, instead of JSON, we are going to use Avro, and we are going to use the schema registry. You don't have to change the complete data pipeline. You need just to change the source table definition. And you just need to, instead of say it's JSON, you say it's Avro, and this is the schema registry URL and how you, the username and password that you use to connect. And that's it. The rest of the SQL pipeline remains the same. You don't have to change anything else. So this is the beauty of having a platform which is is not source agnostic, but the data pipeline definition, it is source agnostic, because you defined a table from the Flink perspective over your data source and your data target. And the main chunk of your work, which is defining the transformation, can remain the same.
Thank you both. That was a really good answer. I'm curious to know if anyone in the chat has any questions, because we actually threw the list of all these submitted questions. So perhaps let's give it a minute or so. In the meantime, Francesco, Martijn, do you have any final words of wisdom to anyone working with Flink SQL or anyone starting with it that you haven't mentioned yet?
Martijn, you want to go first?
Yeah, I'm thinking. I think my last piece of advice that I would like to give to all the viewers out there is to don't be afraid. Just start doing it and try it. The moment that you run into issues, there is a huge Flink community out there that is more than willing to help you out with your user questions. You can find more about the community on the Flink website itself as well, where you can reach out to them either via email on the Flink user mailing list, or post your question on Stack Overflow from their perspective, tag it with Flink SQL, and there will be multiple people in the community who are actually monitoring those questions and try to help you out. Don't be afraid, ask your questions, and get started.
I believe from my perspective is start easy. So one of the things that I experienced when I started with streaming was the complexity of, for example, finding a streaming data source. So if you want to learn Flink SQL, take out all the possible other variables. So don't, like my experience or my suggestion is, don't spend a week trying to install Flink by yourself. Because, you know, most of the times you will never do that. There are services like Aiven. There is also other platform like Ververica that can offer you an easy installation or a completely self-managed installation. Or you have the Docker. So with Docker, you just clone a repository, one command, and you have Flink SQL there for you. So you don't have to spend a week in trying to understand how you install and you make all the services talk with each other, because it's already there. And as I said, well, you might be interested into knowing that, and that's another topic. But if you're interested into Flink SQL, just start from a place where you just have to think about the SQL and define your data pipelines. The last bit is finding the streaming data source. This is also something not easy. And the Flink Faker producer allows you to just define a table in Flink and define the columns. And for each column, more or less, you can define with regular expression what each column does. Once you define that, you have a streaming data source that you can use in order to test your data pipelines. So start with those two. Start with either Docker or a completely managed platform, and then start learning SQL from there.
Thank you both. That sounds like a really good way to end the session, to inspire people to work with Flink SQL. It seems that we don't have any questions from the chat. And since that is the case, so perhaps we can close the session a little bit early and win back about 10 minutes of our time. I really enjoyed today's AMA. It was really good questions, some good advice. So thank you both, Francesco and Martijn, for your input. And thank you to everyone who joined us today. You will find the recording of the session directly on the channel, and the list of resources will be posted in the description box below. And yeah, once again, thank you, and have a nice rest of the day wherever you are.
Thank you very much. See you soon. Bye-bye.
Bye-bye.